Zombie Apocalypse.
Okay, this time double integration method, but applied to another type of a statically indeterminate beam, which is what we call restrained beam. So a restrained beam is called a beam support that has both fixed support. So both sides naman is talaga naka-fix na. So let's get ready to be neurarized. Okay, suppose that we have this beam. So again, this is a restrained beam, and its property if both sides are fixed. Yun naman ang property niya. So we are to calculate the shear at A, the reaction moment at E, slope at C, deflection at D, and of course, the maximum deflection. This time around, deflectional rigidity is set to be constant. So this will be our figure of analysis. So we will try to assume again the direction of the reaction. Of course, for the fix, we have shear and the moment. So notice that I have assumed both shear are upward and both moments are clockwise. So it's okay. So eventually, kukorek ka din naman later. Pag may nag-negative, that would be the other direction. So if MA is negative, then it should be counterclockwise. Again, I'm expecting here that moment at A is negative because we know, as I discussed already, because of the nature of the bending, so it will project a counter resistance like this. So this will depict the moment reaction at both supports. Okay. So to continue, how do we proceed now? So again, using the rule of double integration method. So the leftmost part would be the 0, 0 coordinate, and the rightmost segment should be the point of the cutting portion. Okay, just like this. So those are the points that we need to understand. And notice that there are multiple loads that we need to continue for the load computation. So for this, para hindi kayo malito or hindi makakalula sa computation, you can make the you can make the load to be separately computed, or what we call the superpositional computation, as discussed already from statics of rigid bodies. So we will apply here. Okay, para maging madali analysis, so we will try to separate them and to be used in an equation. So notice that the load reaction located on segment BC hindi po nakadikit sa cutting plane, while the load on reaction DE, no, nakadikit sa cutting plane. Ito yung BC, no, sinasabi natin, no, hindi siya nakadikit, may gap pa. So what do we need, no? Yung unang superpositional member natin, i-continue natin as discussed already before. So that's why we need to continue the slope. Okay? And then, notice that there's a trapezoidal area. So, actually, pwede mo siya i-drawing din na parang pag ito. But, again, in my language, it won't be cute, no? Na ganito load computation natin. So, we can apply mirror image application. Na, kunwari, nag-drawing ka ng triangle dito, o ganyan shape, pag mirror effect mo, the other way around. Parang ganyan siya. Yan. Mirror effect. Pwede naman yan. But, that will have the same answer. So, to make it more elegant looking. So, therefore, that would be the case just like this. Okay? So, may makikita kang trapezoid sa baba. O, gawin natin isang rectangle sa isang triangle. So, just like this illustration. Okay. So, yung 5 kasi natin, mula dito lang. So, therefore, this would be also 5. So, ngayon sa dulo, it can be traced so by using triangulation. But we are under the interest yung hanggang cutting plane lang. Hindi yung pinakabuo. Just until the cutting plane, just like this. So, we will name those points into new letter assignments, variable assignments. Okay, so this would be our analysis. So, of course, the red colored loading triangle is our y sub 1. And the blue equation, that is rectangular load, which is uniformly distributed, which is 5. And y2, yung triangular load, which is y sub 2. So, notice that the beta or the angle of this triangle, ito, yan, if this is beta, this is also beta, no? Kasi dito siya nanggaling din naman. This is also beta. Yan. So, knowing the principle of trigonometry. So, yung sa 3 kN per meter, wala na tayong gagawin dyan kasi nakadikit na siya sa cutting plane. Otherwise, we will do the same. No? Yung reorientation of the geometrical figure that is already discussed in my past video lectures here in this Theory of Structures playlist under double integration method. So, by that, we can now derive pi ports. Kasi original load natin, this is 1, no? The pi ports equals y1 over x minus 1 and equals y2 over x minus 5. So therefore, y1 and y2 are pi ports of x minus 1 and pi ports of x minus 5 respectively with a pointed parenthesis as introduced here. So this will be our equation EIY double prime, hindi pa simplified. And notice that the load that is located below will execute an upward direction. So doon in for violet, if you can see it, I think hindi siya makita. So that's not the green color. I try to use other color to say black. Yeah, the black color loads. So pataas yan, ito naman ay pababa. Okay. So therefore, of course, the 3 kN per meter is also going down. So we can now generate this full equation. Again, projected to the cutting plane portion. So therefore, replacing y2 and y1, so as we simplify it, we'll get the following. Okay, so ito po yung simplified equation natin sa EIY double prime by using the y1 and the y2 equation here. So by that, now integrating once, we'll get EIY prime. Integrating twice from the original equation EIY double prime. So that would be our equation. So we need to eliminate the arbitrary constant, although the maximum number of unknowns are 4. Shear A, moment at A, and the arbitrary constant C1 and C2. Again, same property. Magsimula ka sa pinaka malapit na 0-0 coordinate reaction, which is exactly 0-0 at the fixed support at A. So using the important or essential property of a fixed support, both y and y prime, or the deflection and the rotation, are held 0. So you'll be getting both C1 and C2 is 0. So at X is 0, Y is 0, then C2 is 0. Because again, by the discussion, 0 minus 5 is 0. Okay? 0 minus 1 and 0 minus 6 are all 0. So of course, this is 0. X is 0, right? So therefore, C2 is 0. Also, if Y prime is to be concerned as for the elimination of the arbitrary constant, then Y prime is for 0. This is 0. 0, 0 minus 5 is 0, 0 minus 5 is 0, 0 minus 1, and 0 minus 6 are all 0. So C1 is 0. So what do we have here is the remaining unknown for shear A and MA. So looking on the other support reactions at E, so that is at X is 10 meters. So at X is 10, Y is 0 again because that is fixed support. So we'll generate this equation using EIY equation, okay, to renew. So therefore, all of the equations will be used. So therefore, we can have this first equation, 500 turns of shear A plus 50 MA equals positive of 1,453 over 3. Likewise, for at X is 10, Y prime is 0. So therefore, we'll be using the EIY prime, this one. Again, C1 is 0, don't forget that. Though we will get this now, 50 VA plus 10 MA equals positive of 237. Again, two equations to unknown, you will get the following. And notice that MA is negative, meaning our assumption is incorrect for the rotation. So to correct this, so the answer would be since shear A is positive, so it is 1051 over 125 kilonewton that goes up, while moment at A is 917 over 50 kilonewton meter that is on the counter direction. So kasi kanina clockwise, so gawin nyo na siyang counterclockwise. Okay? So the answer for A is this one. No? Shear force reaction at point A. Now computing for the reaction at E, performing force vertical equals 0, and based on statistics, we can use this, upward equals downward. then turns out to be positive, shear E. So therefore, we will accept this value, shear E, as 1699 over 125 that goes up. And moment at E, no? Clockwise equals to counterclockwise, or if you want, you can use positive clockwise, negative counter. So, what I did here, lahat ng kumontra sa rotation ng moment at E, positive, lahat naman ng with the direction or kasama ng ikot, kaparehas ng ikot sa moment at E is negative with respect to point E, relative to point E. So, therefore, we'll get this. So, you can use your statics for this. Just like, ang shear A kasi natin, iikot din naman na clockwise, kasi ikot siya ng moment at E. So, moment at E tayo. So, shear A will rotate clockwise. So, same sila. Kaya, negative. Eh, yung moment at E natin, counterclockwise na. Okay? So, therefore, it is positive kasi magkabanggaan sila ng ikot. And the rest is following to the said principle. Ito sa rectangular, sa triangular, at sa rectangular, they will both counteract with the rotation of against the rotation of moment at T as assumed. So therefore, we'll get positive 3239 over 150 kilonewton meter. So you can validate this if you want, clockwise positive, negative counter, then equate to 0. You will have the same answer then. So that would be the answer for letter B, the moment reaction at point E. So counterclockwise. Sorry, it's clockwise. I mean, that is clockwise. Like positive kasi. So therefore, my claim for my discussion before is true. So I already discussed in many ways how do we predict the outcome of the moment reactions based on bending, potential bending due to the load. So again, let me go back to a value of moment at A that is negative. Para hindi ko nabaguhin yung equation ko, let it be positive, but note that MA is negative of a value, so therefore positive times negative is also negative. So it will be the same kung i-correct ko na yung moment at A, so immediately negative din naman siya. So I will stick to the assumption that is incorrect, but yung moment kasi natin sa A is already negative, para ikinokorrect na rin naman niya anyway. So to continue, so for me to find the slope at point C, so locate point C at X is 5, okay? So therefore, you will get 1 over 15. So ano yung mga magsisiro dyan? So 5 minus 5, 0. And 5 minus 6 is 0. Tanggalin na sa system. And then it is positive. So we know that the positive tangent of an angle is first or the third quadrant. Kapag ka negative, second or to the fourth quadrant. That was already discussed in my past video lectures. Okay? So that would be the answer for letter C. And for us to find deflection at D, locate point D at X is 6 based on the figure. So therefore, we can now have this equation. No? So ano ba magsisiro sa EIY? So that would be the following. So lahat ng magsi-6 or magne-negative, 0 or magne-negative will be removed. Of course, that would be 6 minus 6. And the rest will stay. So for validation, you can calculate. And then after this, you can have EI delta D as negative 22412 over 375 kilonewton cubic meter. So, negative means a downward deflection. So, that would be the answer. Ngayon, magtataka kayo, bakit hindi ko na multiply ng 1,000? Diba, nakasanayan natin, pag bumultiply ka pa dito ng times 1,000 cube, right? At dati, sa deflection, mag-multiply ka ng 1,000 to the fourth. Why? Ang EI kasi natin is constant. You don't know right now kung anong unit ng ating EI. So, therefore, if that is the case, do not reconvert or convert the value of the EI theta C or EI theta and EI delta, let it be, and then divided by immediate value of EI, just like this. So, i-convert nyo lang ng tama kung alam nyo kung anong values at saka unit ng EI. And then you do the dimensional analysis computation. So, again, kapag ka-constant, you have to divide it just only to EI. EI lang po. Okay? So, so ganun din naman principle natin sa maximum deflection. So, lagi naman ang deflection is maximum at y prime is 0. So, what is x? So, let's try to find out. Let's say my guess value would lie on CD. So, therefore, the limiting distance is 5 to 6. Okay? So, using y prime as 0, so, using shear A and MA values like 1051 over 125 and negative 917 over 50. So, ano pa yung mga magsisiro dyan? If you use the extreme limit 6, so, ito 6 minus 6 lang yung si 0. So, therefore, you can have your quadratic equation. Actually, this will be quadratic kasi magka-cancel out yung mga third root equation nila because of the commonality of the 5 over 96. Okay? So, therefore, that would be 4.996 and 18.0299. Both are not okay because the limiting distance is 5 to 6. So therefore, we cannot accept. But what is good, we are being given a hint kung saan pwede siyang mahanap at 4.9936, which is located at segment BC. So nasa segment BC potentially maximum deflection. We cannot apply 18.0299, no, kasi napaka-laki na nito. That is above the, more than the length of the beam. So therefore, using segment BC, since we are given the idea kung saan natin pwede i-locate yan, then recalculating. So the limiting distance of segment BC is from 1 to 5. Okay, and using 5. So ano ba yung magsisiro na dito? So medyo marami na, no? 5 minus 5, and of course, the x minus 6. So that's why this equation exists. Then you can have the 4 equations. So actually, itong negative 0.002 is already 0 eh. And we will expect that it's either 0 or the maximum span of 10 will be one of the roots since both sides have a slope of 0. Hindi lumabas yan, therefore there's something wrong with your computation. It's either 0 or the maximum span should be one of the value. Negative 0.0020 is already 0. So we cannot accept negative root. We cannot accept 7.8715. Pero baka magduda kayo, baka magkaroon ng ano ito, ng double curve. Kasi ang 7.8715 is located at segment DE, right? So therefore, for the meantime, ang 4.9936 nagkataon nagka-equal sila because the load values are small, 5 kN per meter and 3 kN per meter, napakalit eh. Kaya minsan nagkakaroon lang ng konting discrepancy sa more than 10 thousandths of a place eh. But again, you have to recalculate it to safely provide the values of x. Okay? So therefore, we will accept this 4.9936, but please do not assume that kahit i-recalculate mo, same yung lumalabas. Nagkataon lang kasi yung load natin is napakaliit. Wala pa tayong concentrated load na in-apply. Kaya theoretically, almost the same, but not really equal. But later, we will try to appreciate yung 7.8715 kasi pag ito nag-exist, nagkaroon pa rin isang root na on segment D na itong value. Therefore, there will be double curvature. Now, if you try DE, so the segment is 6 to 10, so on your scratch solutions or your verification, so all of these equations will exist, no? EIY prime natin. Because 10 minus 6, 10 minus 5, 10 minus 1 are positive, then you can come up with this. So lumabas dito, 4.957, negative 4.957, and a positive 10, which is okay to 10. No, talagang y prime 0. Pero notice that these two equations, kung nagsimula kayo sa DE, hindi po siya makikita sa segment DE. At ito ay nagsisimula, makikita rin sa segment BC. So therefore, in short, what would be the lesson here? Kaysan ka mag-assume, meron isang root doon na ibibigay sa'yo kung saan siya dapat hanapin. Which is, nangyari na wala palang double curvature na nangyari. So therefore, the validation for BC is correct. So, deflection maximum is located on segment BC. Now, to continue, using at x is 4.9936. So again, using EIY equation. So ano yung mga magsisiro dito? Yung mga may x minus 5, okay? And also x minus 6, tanggalin na natin yan. So you'll get negative 64.7502 kilonewton cubic meter. Again, negative means a downward deflection. So therefore, since wala namang binigay na unit si EI, so therefore we divide it by EI. So the answer would be 64.7502 over EI. That goes down. So that is the answer for letter E, the maximum deflection. So by this moment, we have completely discussed double integration method. Now, next topic would be area moment method. And notice that all of the problems solved by double integration method will be solved again, but this time that we are going to use area moment method. So therefore, will they give the same answer? Let's find out. Thanks for viewing. I hope you learned something new today. And again, as our tradition goes, you have been neurorized, and see you in our next video lecture. Coming up next, area moment method, one of the highly versatile topic and methodologies of computing deflection, and rotation, and can give us with a higher advanced method that will be appreciated in one of my playlists. So see you in our next video lecture.